Hello friends, let us start our session Transition Elements and Ionization Energy. Here we will study how ionization energy varies in transition elements. It is the topic we have to study. Then myself is Lubana C. Then let us start. What is transition elements? Transition elements are D block elements. We know that there are four types of block in periodic table for represent elements. That is S block, P block, D block, and F block. Then transition element includes in D block elements. Their position is from group 3 to group 12 in periodic table. Then their last electrons enters in n minus 1 d orbital. N is principal quantum number of an electron. We studied what is principal quantum number in previous classes. Then they are partially filled in its atom in ground state or in of its oxidation states. Either of these states they are partially filled. For example, titanium is in ground state. It is partially filled in its ground state because the outermost shell is 3d2. It is partially filled. Okay, the maximum number that can carry by and d orbital is part 10. Here only we have two. It is partially filled. Okay, so it is transition elements. Then we take copper. Copper has the outermost electron in its ground state as 3d10 and 4s1, but it is completely filled. Okay, but in its oxidation state, what is oxidation state? Plus 2. Copper's oxidation state is plus 2. And we remove one electron from 4s subshell and another from 3d subshell. The remaining is 3d9. So it is partially filled. So in its oxidation state, copper also uh, transition element. Okay, copper is transition elements because it can represent as partially filled electronic configuration in its oxidation state. Okay, then we have to go to ionization energy. So what is ionization energy? Ionization energy is nothing but this is the energy required to remove an electron, a single electron from outermost shell. It varies along a series. The first ionization energy increases along a series. The first ionization energy is the energy required to remove an electron from outermost shell. Okay, that is the ionization energy. The common term is ionization energy. When we remove another electron, that is we called second ionization energy. Okay. Then how first ionization energy increases along a series. When we move from rough to light, there is increase in effective nuclear charge. We add electron when we move left to right, from left to right. So nuclear charge also increasing. Then there is decrease in atomic size. So overall there is increasing attraction between nucleus and outermost electron. Then we have to go to the final session. What is the difference of ionization energy in 3D series? For 3D series, the ionization energy is that is the first ionization energy is the removal of a 4s electron. When we remove a 4s electron, there is a relative energy change from the 4s to 3D. That what is the change? There is the energy, the relative energies of 4s and 3D subshells altered. Then 3D subshell will have lower energy than 4s. Okay, 3D subshell will have lower energy than 4s subshell. Then next is when this occurs, there is transfer of electron from 4s to 3D and some electron gain energies also happened when this transfer of energies occurs, transfer of electron occurs. That is the some irregularities occurred. When we take titanium and vanadium as examples, Titanium has a higher ionization energy than vanadium because the removal of one forest electron and another change and the subsequent transfer of remaining forest electron into the 3D subshell bring more gain in exchange energy for what vanadium than titanium and will have lower energy also for vanadium. The final electronic configuration will like this 3D 4 and here 3D 3. Okay. Thank you for watching my lesson. Hope you understand.